This is LING 270, Language, Technology, and Society, Module 6, Artificial Intelligence. In this lesson, we'll be talking about definitions of intelligence. So to begin this module, it's really important that we define our terms first. In particular, we also want to see when we talk about intelligence, we most frequently talk about a human being intelligent. So we'll talk about how we define the properties of human intelligence first. Then we'll go on to discuss how can we determine if a machine is intelligent. And we'll discuss two thought experiments which have been developed towards this goal, namely the Turing Test and the Chinese room experiment. And finally, we'll discuss what limit there may be for an artificial system to be intelligent. And there's a lot of disagreement about this. Some believe that an artificial intelligence system can become as intelligent as a human is, or even more intelligent. And individuals who believe that would believe in the strong AI hypothesis. Others are more skeptical and believe that an artificial system can only imitate human behavior, but is fundamentally not the same. But the intelligence that a machine has is fundamentally different from the kind of intelligence that a human has. So this individuals who believe this would believe in what we call the weak AI hypotheses. So we'll go on to discuss a little more about the details between these two hypotheses. So in this lesson, we'll talk about, and throughout this, this whole module, really, we'll be talking about, is it possible for machines to be intelligent? But first of all, we have to talk about what does it mean to be intelligent at all? So it would be helpful to look at a dictionary definition for intelligence. So Merriam-Webster defines intelligence as the ability to learn or understand or to deal with new and trying situations. So we can see that fundamental to this idea of intelligence is the ability to learn, and also to understand. So that means that an intelligent system has to be able to interact with its environment in such a way that it can find patterns within it. And what's also important for intelligence, which is also in this definition here, is the ability to deal with new situations. So the system has to learn things in such a way that it can be able to apply that knowledge in new situations that it hasn't seen before. And we'll see in the development of artificial intelligence systems that this is a very critical aspect to intelligence as well. And we'll also be talking throughout this module the idea that if a machine is human-like, does that necessarily mean that it is intelligent? So there is disagreement about this. So we'll go into more detail in this question especially. So let's begin with talking about this idea of human intelligence. So the idea of intelligence is closely related to the ideas about the nature of human consciousness. And there are two kind of different approaches as to how we can describe our consciousness philosophically. Some will take a dualistic approach, which is to say that consciousness is a kind of thing that is fundamentally separate from the world around us. So there are basically two entities in the universe. There's the mind and there is matter, or in other words, the subject and the object. So since mind and matter are two fundamentally different entities, that means that the properties that describe each of them are unique. In order to describe the mind, you need a different set of properties than the properties which describe matter. And there's also a school of thought called materialism, which is to say that all of the universe, including consciousness, consists of matter. And that if you want to understand anything, including mental states, you can understand that by studying the nature of matter. So for example, a materialist would argue that we can understand natures of human consciousness by understanding how the biochemistry of our brain works and how the physical properties of our brain work. And we can probably conclude as well that a materialist would probably believe that if a set of material can become conscious as it does for a human, then we could artificially create a electrical circuit which can become intelligent as well. Dualists may disagree, though. Dualists may believe that mind is something that is fundamentally separate from matter, and it is thus something that can't be constructed. So these are kind of interesting ideas about consciousness that we might want to think about when we're talking about the ideas of artificial intelligence. Another idea that comes from psychology is that intelligence is actually something that is really a very multifaceted skill. So there are many different kinds of things that we can learn and apply to new situations. Individuals may be intelligent in one way, but not intelligent in other ways. So the psychologist Gardner identified several aspects that could be considered intelligent, such as interpersonal skills, or linguistic skills, or naturalist skills, or musical skills, or logical and mathematical skills. So we can see, and you could probably maybe identify in yourself and others, that there might be some skills which you find relatively easy, while others are more difficult. So we can see that intelligence is really something that is kind of multifaceted, especially when we're talking about humans. So that it's good to keep this in the back of our minds when we're talking about what human intelligence is. So now let's move on to talk about how machines can be considered intelligent. And a major pioneer in this question was the computer scientist Alan Turing. So Alan Turing is known as one of the fathers of computer science and made major advances in cryptography as well. He is particularly famous for developing the concept of a Turing machine. So for those of you who might not be familiar with theoretical computer science, a Turing machine is a mathematical model of a computer which can be used to prove the computability of certain problems. So it is a very fundamental concept in the field of computer science. Alan Turing also played a very pivotal role in cracking codes for the British government during World War II. Some have even estimated that his role was so critical that it actually shortened the war by 2 years. This quote just kind of goes to show how important Turing's expertise was to the war effort. Turing worked a lot with what could be considered worked a lot with computing technology. And this led him to consider a lot about the potential intelligence of machines. So he made a lot of very interesting comments about the potential intelligence of machines. In particular, he developed this concept of the Turing Test, which many of us are familiar with today. So the Turing Test, which has become so famous, was first proposed in 1950 in a paper called Computing Machinery and Intelligence. So this is a paper that is part of your assigned reading, it is very foundational for this idea of determining the intelligence of a machine. So as I've kind of alluded to when discussing intelligence, intelligence is a very complicated concept and a very multifaceted concept. So maybe it's not really a good idea to define what intelligence is. So instead, we can work around this using an alternate experiment. So what we can do instead is collect a machine that is capable of doing a particular task, as well as a human, and tell them both to create a text output based on a certain question. Then these two outputs will be presented to a human judge, and the human judge has to determine which output came from the machine and which output came from the human. So we can see in this diagram on the right here, there's a human C who is seeing a text from a machine and a text from a human. Now, the human is is behind a barrier, so the human can't actually see whose output is whose. So the human has to determine, just by looking at the text, which one came from the machine and which one came from the human. So the idea of the Turing test is to say that if the human can't tell the difference between these two texts, then the machine can be considered intelligent. So in other words, the Turing test avoids this idea of defining intelligence by saying intelligence is something that a human just knows when a human sees it. So if a human can't tell the difference between the behavior of a machine and the behavior of a human, then we can say that the machine, for all practical purposes, can be considered intelligent. Now, the thing is, it is somewhat disputable to say that just because a machine can mimic a human just in terms of behavior, that means it is really internally intelligent in the same way that a human is. So some dispute this idea of a Turing test to prove that a machine is actually intelligent in the way that a human is. But nonetheless, this idea of a Turing test is a good way of assessing the quality of a machine. It is at least useful, an idea to know that a machine can perform, at least in outward appearances, as well as a human can. So the Turing test is nonetheless a very useful concept. And one way that the Turing test has actually been used in a way, and which many of you are probably familiar with, is something called a CAPTCHA test. So CAPTCHA is an acronym that stands for Completely Automated Public Turing Test to Tell Computers and Humans Apart. So a very creative acronym. And it is used by a website to determine that the user, probably someone trying to log into a website, is a human instead of a bot, or instead of a computer system. So a computer system, for example, may try to log into a website by trying many possible passwords. So the owner of a website may want to verify that a person trying to log in is in fact a human and not a machine. So this is a key way to prevent brute force attacks on account passwords. So the idea of a CAPTCHA test is to present the person or machine trying to log on with a problem. This could be being presented a word, such as the word in the top left or top right image, which has been obscured in a way. And so this is a problem that should be very difficult for a machine with an image processing system to handle, but very easy for a human visual system to identify. Another kind of CAPTCHA test could be being presented with a set of images and asking the human to select all images which have a storefront. These are tasks which can come very easy to humans, but they require a very sophisticated machine system to solve. So in this way, they are good ways of discriminating humans and computers apart. We can see that this test is called a Turing test in a way because it is very closely related to Turing's idea, which is to say that if we present these kinds of problems to a human and a machine, the intelligent individual should be able to complete it, while the not intelligent system should not. But this CAPTCHA test is a kind of inversion of the Turing test in a way, because the judge here is the computer, namely the website itself, rather than a human. So we can see this idea of a Turing test is very important and has been put to use. So as I talked about a little bit earlier, when we're talking about the Turing test, we're only evaluating the intelligence of a machine by looking at its outward appearances. And that might not necessarily mean that what's going on inside the machine is the same as what's going on inside a human. So it might not be the case that a machine is really intelligent as a human is. Maybe it is just mimicking human behavior. So individuals who are skeptical about the power of artificial intelligence would subscribe to what we call the weak AI hypothesis. So the weak AI hypothesis states that it is possible to produce machines which can exhibit intelligent behavior, but that doesn't mean that that machine is really understands the task or in the way that a human does. And the weak AI hypothesis also claims that the way that an AI system works internally is very different from the way that a human mind works. Now, there are some who are more optimistic about the abilities of artificial intelligence. People who describe to this hypothesis would say that machines can be programmed to possess intelligence in the same way that humans can. A strong AI hypothesis might make the claim that the complex physical interactions that happen in a computer chip are basically kind of the same as the biochemical reactions that are happening in the brain. So we shouldn't really be surprised if we could construct a machine which is as complex and as intelligent as a human is. There's a lot of dispute between these two hypotheses as to how intelligent an artificial intelligence system can actually become. One thought experiment that we can kind of discuss to kind of determine whether the strong or weak AI hypothesis should be correct is to use the Chinese room experiment. So this was proposed by the philosopher John Searle in the year 1980. And it's a thought experiment that kind of works like this. There is a room with a door with a little slot in it, as you can see on the figure on the bottom right here. So what you can do is you can write messages in the Chinese language onto a piece of paper and pass it into this room. And inside this room, there is a person who does not speak the Chinese language, but has a large manual inside that has a large set of instructions telling him how to respond based on what he receives in the slot in the door. An instruction might look something like the image in the top right here. So if you see these shapes followed by these shapes, then produce these other shapes. So the important concept here is that the individual in the Chinese room doesn't actually speak the Chinese language, but has instructions as to how to formulate a response. And once this individual makes his response, he can put it back through the slot and possibly give the impression that the Chinese room has understood the question. Now, so we're going to ask a question with this thought experiment. Does this room, or does this individual in the room, really understand Chinese if they're just following the instructions in the manual? So Searle would claim that that this thought experiment shows that the strong AI claim, namely that intelligent systems can be considered intelligent if they just exhibit intelligent behavior, he used this thought experiment to say that this is false. So we can see that really the individual does not understand Chinese at all. He's just following the instructions that have been written in this manual here. But now this thought experiment is not conclusive, however. Some still disagree, and some still believe that it is possible to make an artificial system which is intelligent in the same way that a human is intelligent. In particular, you might want to wonder to how possible is it to create the manual in this Chinese room here, and what if that manual can be created and updated as the the Chinese room exists. So those are some questions to consider as well. But in general, it's important to, when we're discussing the idea of intelligence, we have to consider what is going on inside the machine, as well as what is the machine actually behaving externally. So we need to make that internal and external distinction. So to conclude this lesson, we talked about how intelligence is a very complex and multifaceted concept. But in general, we can say that intelligence is the ability to find patterns in experiences and apply them in new situations. We talked about the idea of the Turing Test, which essentially asks, can a human judge tell a human and a machine apart? If the human can't tell these two apart, then we can say that the machine is intelligent. We also talked about the Chinese room experiment, which asks the question, is a person or a machine intelligent if they simply follow instructions? So this is something that a lot of artificial intelligence systems do. They may simply follow instructions. We use these two thought experiments to kind of consider these ideas of the strong and weak AI hypotheses. So we talked about the strong AI hypothesis being that machines can be intelligent in the same way that humans are intelligent. So if we look how a machine, an artificial intelligence system could work, it is internally intelligent in the same way that a human being is intelligent. Others are more skeptical and believe that artificial intelligence systems can only imitate human behaviors, but are fundamentally different from human intelligence.